from Nokia. I'm pretty interested.
Hey. All right, so initially I wanted to do a talk just about managing Puppet with Jenkins, but kind of when I built the slides came to the conclusion that it's not that useful. So I'll actually try to cover a little bit of a bigger picture on how do we actually provide Puppet as a service using Jenkins and some other stuff around it. My name is Pascal. I'm working at Nokia as the head of automated deployment at the moment. Got a team of engineers that built like an automation solution that manages a bunch of boxes in Nokia at the moment, and I'll go into detail what those boxes actually are and why we have so many machines, because it's not for cell phones. Been with Nokia for about 1.5 years. I started out as an engineer. I still write code despite the fact that they moved me into management because I thought it was a good idea. Before that, I was a site reliability engineer at Google. I wrote automation as well, not Puppet. And yeah. So it's Nokia not just doing cell phones, and really, no. We do a lot of mapping. So Yahoo, Bing, and several other bigger websites are actually relying on Nokia Maps for all their mapping solutions. So for the Germans, I think Map24 is one of the bigger sites in Germany that is, at this point, actually using Nokia Maps as well. And rendering's pretty expensive. Routing is pretty expensive. Creating maps is pretty expensive. So there's several machines involved, a couple of thousand machines that basically need to get managed somehow. So how do we actually do this? So we have an awesome product called Thor, which started out to do everything and ended up actually focusing a lot around how do you do Puppet as a service without putting a big burden on people. So Puppet as a service is really the big chunk that is the interesting piece of the whole system, I think, and that's where I'm going to focus in this talk. We provide extensible integration. What this means is that if you bring up any box, it'll automatically be like monitored. It'll export logs to log collectors. It'll export trending data to training systems. It'll basically be integrated in the company, but we provide small defines where you can actually send it, where you can say, oh yeah, this box actually needs this Nagios check as well, or it needs these data points being exported, which is custom to the machine itself. And we provide a lot of standard building blocks. So things like Tomcat setups, or MySQL, or Apache, or various other pieces of software that are used over and over. We provide recipes so people don't have to reinvent the wheel every single time. So I'll go a little bit into history and how we actually got where we are, because we tried to use Puppet for a long time and we failed a couple of times. So the very first thing, and I luckily was not at Nokia at that point, was that everything got deployed by hand and bash and crazy tarballs and hand-built packages on somebody's workstation. And I think everybody that ever went down that road realized at one point or the other that that really doesn't scale. And it's painful, and you really hate your job, so you should change something about that. Yes. Well, that's the alternative, though. So we came up with the first version 1 Puppet system. Was a lot better than what we used to have. We thought it's a great idea to have 2 environments and the traditional approach where you have some development stuff and you integrate it into a production branch and you run up that, and yeah, that went pretty well until we actually had some fun side effects where you'd have a search indexer get deployed to a map renderer, or a places database that is pretty big get deployed to a search node. Basically, a lot of side effects that we really didn't like too much about the whole system. So we did a bunch of thinking at that point, and had the big target of make this tested so we don't get shot in the foot as often as we did before. We need strict isolation, so we want to version our code, we want to deploy it in a way that it doesn't change when we don't expect it to change. And we want to provide this to a lot of customers. So in in June 2011, we took the first customer on, and at this point, we're at 120 customers internally. So a customer is an R&D team, essentially, that writes some code, needs to get something deployed into a data center. And it's grown rather rapidly still. So what is this whole thing? We have a notion of shared, or of the dist modules is what we call it, which is basically shared modules like the integration modules I was referencing earlier that my team writes, provides, and extends. Those are being versioned. The regular approach to software development, so you have branches or tags. I hate branches, so we use tags. Tags are immutable. You can't try to change them, it won't work. And we release those regularly, and the customer comes in and says, hey, I want to build application X, and I need an API, and he picks the latest and greatest of our API and says, I'm going to build my modules against this version of your API. We do a bunch of magic there on the puppetmaster side. I'm going to go into technical details in a few. We have strict isolation between customers and versions. So we're utilizing Puppet environments. So every customer, if they decide to build a version of their modules or create a tag, it's going to be a separate environment on the puppetmaster. We control the environments of the clients through an ENC that we built, and we work around the bug that was referenced in the talk right before me. And it's pretty painful to do so, so I'm looking forward to switch to 3.0. We do a lot of testing of the code, so there's syntax checking, compile time checking, and several other things that we do there. Puppetmasters are automatically managed end-to-end, so they're automatically deployed. Modules automatically get installed when something new comes out that should be on the puppetmaster. They automatically grab it, and there's no involvement at all. And I'll go a little bit into the details what we do. We expose configuration to customers through an ENC. So we run data centers globally in a lot of places. So in London, the syslog server would be X, for example. In Atlanta, that would be different. So we expose those variables to customers so they can consume it, and they just say, I need a syslog server that I want to speak to, and they don't have to deal with the rest. I'll show a little bit how we do it later. So what really is Puppet as a service? This is a high-level, pretty ugly diagram, and I don't like colors or anything. I see this as an engineering diagram. So it's really a three-step process that we're currently having. So the first thing is that you write some code, write some Puppet in a repository, and you commit your code. We then do a bunch of syntax checking, and this is all based on Jenkins. And I see that the arrows are going the wrong way, but never mind. We do syntax checking of your recipes. If the syntax is okay, we actually package them up in an RPM. So this makes it easier for us to do the next step, which is the compile time checking, where we used to use Vagrant to bring up VMs and inject the RPM into the VM and run those recipes in a no-op mode. The no-op is more about the nature of the applications we run than actually about you could run it in regular mode and actually build a node. It won't really work with a lot of the Nokia applications because it's more distributed RPC applications, so there's a lot of external dependencies, and dealing with that would definitely be too complicated for a user to easily write a test real quick. So we do compile time checking there. We build a catalog, we make sure that works, and if all that stuff worked, we assign the package and we ingest it into our Repo Manager. The Repo Manager is a small piece of software that we wrote in-house that is a simple RESTful API where you can upload your packages into a repository space that you have. It'll, under the hood, create the YUM repositories. It'll distribute them afterwards. So we actually make sure that as soon as you return from ingesting a package, it's available in all data centers globally. Bunch of proxying and replication that we're doing at that point. This results in a YUM in the data center somewhere. And the puppetmaster basically has a small script running that just says, hey, which packages do I need, which packages are there, and just installs the packages that are required on there. The packages contain an environment, and I'll show how that's actually built up and how we link all that. And the ENC then manages these environments depending on what you configure your nodes to. So it's pretty simple. It definitely ends in awesomeness if you do it right. But let's actually look at a little bit more detail here. So managing lots of environments can get really, really confusing. And if you don't have a system where this is completely automated, usually it's a recipe for disaster in the longer term. We tried to manage environments by hand at the beginning in the version 1 Puppet system, and people would pick the wrong environment more than once and end up with a lot of results that they didn't really hope for. So we really version Puppet modules from one end to the other. So in this case, this is a path in one of the repositories just on the local box that kind of gives you an idea how it's structured. It's a standard software development repo in the end. This is an application called MapsWeb in this case, where you see that they have a bunch of tags, which is their versions, where they release their code. And they actually couple the Puppet recipes with the software revisions that they roll out as well. Bunch of versions there, and trunk, which is where they do their development, and in trunk you actually see how it's structured. So they have a lot of different modules in their tree, and one mysterious file called the metadata YAML that is sitting in there. So this metadata YAML goes back to these dist modules that I was referencing earlier, where you say you want to build against a certain version of the API that we release, and this metadata YAML specifies that for your release. So in trunk, you say at the moment in this case that the application MapsWeb, their trunk is going to build against release 30 of the Thor API that we release to customers regularly. When they want to upgrade, when we release a new API version, they basically just update that file. It'll get rebuilt. It'll get linked against a different library version. And that way we make sure that the coupling is completely tight and is not going to change. So when we change the API in trunk, when we do development, we're not going to affect any customers. There are some customers that are smart enough to run against trunk of our API. It's usually a pretty bad idea. We actually break their builds if they try to do that with a tag. So we had several customers that were rather surprised that their production would change quite regularly, because they were running their tag, which they had in production, and thought is immutable against our trunk of the API that we released, which means every time we did an API change, they basically had that in production within a couple of minutes, which is really not what you should aim for. So this is what it actually looks on the Puppet Master. So we do nasty sim linking to put the modules together. This was a decision we made at the beginning when we designed the whole system. We would not do it again. Symlinks are pretty cool. Managing symlinks through RPMs is slightly less cool. And it becomes very funny when you want to actually extend this. So we get a lot of customers that now request like, oh, this other team wrote these modules. We'd like to use them. So can't we just build against a version of these other teams' modules? And we looked at it first, and it sounded like it's pretty easy to implement until we had some fun issues with namespacing and scope in Puppet, and we didn't really know how to actually import those. How do you order those? How do you structure a module path to actually do the right thing when it comes to resolving the modules? So don't use symlinks. Do this one level up, integrate the namespaces together, and do that at build time, so customers actually will test the right thing as well. This is going to be a major restructuring of the system that we have when we go down that route. So this is a tiny snippet of the ENC that we're currently running. I was saying earlier that you just pick the right environment. So environments, as you can see here, it's called MapsWeb_trunk is the folder up there, which is essentially the environment name. So it gets put together on every node that we have has a definition, and every node has 3 attributes, which is an app, a role, and a release. An app being, well, the application container, so the part of the repository where your modules live. The role being like, is this a front-end server, a back-end server, database server, or whatever it is, where we specify like which Puppet modules actually get instantiated. And a release is the release of the Puppet code that you want to run. So in here, we support tags, branches, and trunk. And it just gets substituted together. That's the environment that gets returned to the client. The workaround we have to get around the fact that the server is not authoritative to dictate the environment is actually that every time the ENC runs, we check if the environment that we would give to the client is the same that it got in the last run by looking at the YAMLs of the last run on the master. If that's not the case, we send a Puppet recipe through the ENC that does nothing else than configure your Puppet conf and schedule another Puppet run. Not nice, but it works. So testing. This is really where the heart of the system is at the moment, or is going to stay as well. We force testing for every module that anybody writes. We break your build and you won't get your code into production if it's untested. Writing Puppet tests is really, really trivial, so there's pretty much no excuse to not write them. It's 3 lines of code that are going to save you a huge hassle when you try to figure out if your module actually works or not. We love Jenkins, so we use Jenkins for this, and had the great idea of let's actually automate Jenkins end-to-end before actually realizing how much work that's going to be. Setting up Jenkins through Puppet was not terrible. It took a little bit, but we wrote some recipes and it works, and then we found out that there were pretty good recipes out there already. But we pushed it a little bit further. So here's like the output of one of the example pages where you see like we have a bunch of tests, and every time you create a new tag or a new module or whatever, we actually automatically wanted to have those added, the jobs added to the Jenkins. So we have a Jenkins job that manages Jenkins jobs. That basically just goes over our repo and is like, hey, there's new stuff. Should I create a job? And it'll just create the job. One note on Jenkins, if you want to automate it, it really sucks to automate it. It's a giant XML file where it stores state and configuration in one file. So be really careful if you automate it, because you will blow away state and you'll lose slaves on weird moments and all kinds of fun stuff that you got to work around. So this is like the test that we actually do. The very first step that happens is just a bunch of, oh wow, this is awesome to read. A bunch of Puppet applies for every single module there is, just to see if the stuff compiles, and then we test the ERBs just to make sure that your templates actually work the way they should. Once this is done, we do a bunch of packaging. So we're just using create repo. We're debating if we use FPM. We had some bad experience with FPM, so we decided against it. We'll just take your code, build it, and make the right dependencies. So the dist modules are distributed as an RPM as well, just like other applications. So we actually have the dependency in the RPM on the API version we need. We'll build the RPM and take this RPM and shove it into a mock container at this point. We used to use Vagrant, but with I think 1,000 runs a day, we had about 2 failures per day, which wasn't too bad at the beginning when we did not have 1,000 runs. Having 2 failures a day means you'd lose 2 VMs, and the only way to bring it back was to bounce the whole box. So we decided against Vagrant, or actually, I must say it's not Vagrant's fault, it's VirtualBox's fault. But basically we're now just using Mocker. It's like a chroot wrapper. We just ingest data into chroots, we test there, and if the compile of the catalog actually succeeds, we just continue. The next step is using the Repo Manager. It's a very simple RESTful API, and we're just ingesting the RPM into that API. It asynchronously triggers create repo calls. So the issue was that we had so many iterations of this pipeline that you'd have like 5 or 6 create repos running at the same time. This is running on a remote storage on NFS. So everybody that ever had a pretty big repo with thousands of modules and tried to run multiple create repo calls at the same time on NFS, don't do it. The storage guys hated us for doing it, and we hated ourselves because it took about an hour at one point because the I/O just got thrashed so bad. So a little bit more about repository management. The Repo Manager is actually really, really, really simple. I wanted to do a snapshot of the documentation, but I was traveling and I could not get on the corporate network, so I can't show you the documentation for it, unfortunately. It only got 4 or 5 calls where you can say, put a resource, put an RPM into a repository, get an RPM, delete an RPM, update a repo. That's pretty much all the calls it supports. The outcome is going to be a yum repo, and that's being proxied through the same software, and you can just point all your servers at it and work away. We're wrapping create repo with this, and we provide a lot of command hooks, which was the main reason why we actually wrote this. So every time like a repository gets updated, for example, we have a hook that you can either trigger at the beginning or at the end. To distribute data, for example, it's very handy if you just have that. We also now just recently support multi-multi replication, so we're running these repository managers in every data center globally. And if you inject a package on any one of them, it'll actually make sure that it gets replicated to all the others. So we don't have to do failovers, we just do fails. You can basically just, if a repo manager goes away, it goes away, it's fine. You still have lots of them. So managing puppet masters was a pretty good challenge. We're running Puppet 2.6 for legacy reasons, and we're trying desperately to go to 2.7 or 3.0, but it's actually a pretty good undertaking if you have 120 teams work away and they don't, how do I put this nicely? The quality of modules has big variances. And they not necessarily understand what is going to be supported in 2.7 and what will break. So what we actually do at the moment is to roll out 2.7, we're still running 2.6 on all the servers, but we run 2.7 in the background where they don't see it in no-op mode, and we take all the failures that happen and we ingest them into Splunk and basically keep on monitoring what actually breaks and then help the teams to fix it before we actually switch over to 2.7. Which again is a workaround that I don't suggest to anybody, but it really works. The other big problem with 2.6 is it really doesn't scale well. If you have thousands of boxes, hit puppet masters, you're going to be in for a treat. Either you need a monster of a box, or you got to do a little bit of engineering. So this is, again, very beautiful diagram. This is roughly how we run Puppet at the moment. So there's the cloud clients, and lots of them. And then there's a Puppet master, which is one of the Puppet masters that we run at the moment. This is where every single connection terminates. The only real task that Puppet master has at this point is that it's the SSL master, where the certificates get created and they just get synced to all the slaves that you have. And we're using Apache load balancing to farm out the compiling to lots of Puppet masters in the background, where catalogs get compiled and they just get passed back. This setup actually scales really well. We were pretty surprised. Failovers are very easy. You basically, through the ENC that we have, we can just fail over to a different Puppet master, or we just fail over a CNAME. And within a couple of minutes, everybody's going to talk to a different master, and we can do a re-election this way automatically. Puppet master management. So I was saying earlier, like, we couldn't do it with Puppet nicely to install modules with a fairly big rule set in the background to figure out what you actually should install. So we did the same thing that Puppet does and wrote Python in this case. And I think it's still the only piece of Python in Puppet, which is the yum provider. The yum APIs really suck. So everybody that ever tried to write code against them, it's not a joy. So yeah, we whipped up this little piece of code that just knows what it should install, and it usually does the right thing. The ENC is really the key piece, as I was saying earlier, like how we actually do the whole configuration of the whole fleet, how we configure Puppet recipes, and how we go about providing configuration of your Puppet recipes. We heavily rely on parameterized classes. We don't do any crazy scope lookups. That's actually one thing that we monitor in the code base, that people don't do it, because it would be a royal pain in the ass to move away from older Puppet versions into newer ones, especially in 3.0, when this just would not work anymore with the dynamic scoping. So we provide configuration to customers to some extent. So how the ENC works, and I don't have a slide on this unfortunately, is that you have, every node has a configuration. A node has several attributes, like it lives in the data center, it lives in some environment like production or staging or whatever it is. It runs an application, runs some role, various attributes that are related to the node. Depending on the combination of those attributes, we'll attach configuration to them in some order. So for example, you say that first you look, it's like, okay, this node is in the data center London. So you read in the configuration of the data center London, which is just a YAML blob, like the ENC fields that you have, like the vars, the classes, and that's pretty much it. Then you look, okay, now I have my data center London configuration, so I go down the stack. So this application has some configuration that I got to read in. So you read that in and you just do an update of the hash that you have, basically. We have a variable substitution mechanism there where you can say you want to override a variable. So if we provide on a data center level, like a variable like yum server, for example, or syslog server, you can say that on a level further down, you can just override that. So it's like basically an extend and override mechanism that we're using when we built the ENC. This way, we provide a lot of configuration to customers. So the default configuration for a data center is actually the test setup of a data center. And we then overlay a production configuration, for example, for production hosts. That you say, every host in London gets this syslog server, but every host that is in London and a production host actually gets a different one. So it's this hierarchical extending and overriding that we built in the ENC with Dan Bodie actually back then, that we heavily utilize to provide configuration to customers. All these variables are provided by us. We take great care that things don't fail. And if they do, we just update those data center configurations, and within 10 minutes it's rolled out globally. So this has been a great argument for customers as well to not disable Puppet. If you have a lot of customers, there's always going to be the one that does enterprise for a very long time, and he just says, oh yeah, you only deploy and then you do stuff by hand, which is really not how we work. So convincing customers to actually not disable Puppet on hosts so we can use it for auditing and use it to fail over stuff in data centers was actually a huge undertaking. It worked pretty well once we had some DNS server failures, and the people that had Puppet disabled were not so happy. The people that had Puppet enabled didn't actually even realize that there was a DNS failure. So yeah, if you have to argue that one, just wait till something breaks and then you can make a great argument. This is just an example of the configuration of the data center in London in this case. There's a lot of variables that we provide. I think it's mostly self-explanatory. It's just a bunch of variables, and you can just use those in your ENC configuration, and you just reference a variable. And this is basically the interface between, if you have a parameterized class, you just fill in the variables from the ENC into the parameterized class. So you have the propagation from the configuration store into the logic, which is also what Hira does in some sorts. We didn't use Hira because Hira has a strict hierarchy, and we actually wanted dynamic hierarchy. So we basically want the capability to give different customers different hierarchies and different principles of doing inheritance of variables. So with Hira, unfortunately, that didn't work. So the next steps of the whole system. I really like Puppet, but I really think it's not the right tool for orchestration. And a lot of the Puppet guys might hate me for that, because that's really what they're trying to do hard at the moment. We're basically putting a layer on top of Puppet, which is just gonna, Puppet is basically one of the agents that you could trigger. As an example, like Puppet is a deployment mechanism. You could trigger that through an orchestration layer, but we also want to be able to service things like load balancers, firewalls, and other things where we actually need to trigger events on a hard time basis and in a dependency chain where I can't really afford anything to be arbitrary to some extent. So this is one of the things that is going to be in development. Then refine the APIs into config management. As I was just saying, there's a lot of YAML files that we have for the configuration of the ENC. let's just say that Git is not the best data store if you have hundreds and hundreds of developers do configuration stuff. Especially when they're in different teams, and some of them might not be so senior with Git. And you have one developer that didn't quite understand how merges work and blows away changes from the last half hour for all developers. So we put a RESTful API on top of the Git repository that exposes a data model, and are now basically rewriting all the tools and get everybody to go through that API. And once that's the case, we're pulling out the Git repo and shove in a new data store backend that has permission and role management and everything enabled. So users actually can only change the types of, or the attributes on resources that they actually have access to. So for example, a user could not change the data center London configuration. He could change a configuration that is in his app context for the data center London, but basically further down the chain. So there's going to be strict model, again, based on those attributes that we're using everywhere, we will give permission where we say this developer gets access to application is Maps Web, and every configuration attribute that has this attribute set would be accessible for that guy, and he could do changes on it. Same goes for machine access. At the moment, we're using Puppet to generate accounts on boxes. It was not such a great decision if you have boxes where 1,000 people need to be able to log in, because your Puppet runs will take forever. Creating 1,000 accounts through Puppet and just the catalog for it takes like 15 minutes. So it's not that great. Yes. Yeah, unfortunately that one's not that easy, but I'm more than happy to talk offline on why that's the case. I just don't want to have that on video. So we're refining those APIs. We're putting APIs in a lot of places at the moment. The repository management was the first one. Then we just added the configuration API so people can actually trigger changes in the configuration in an automated way. A lot of people in Nokia use Jenkins to do their development, and they actually wanted to do continuous integration in a way where they reconfigure whole environments or data centers on the fly from within their Jenkins job. When they cut a new release, they automatically want to roll it out into a QA cluster in some data center, and they just want to trigger the YAML change automatically. So we wrote that API for that. We want to become more or fully agnostic to the underlying machine types. This whole system, as I was saying at the beginning, we try to solve everything, which is really not the right approach when you want to be successful. So we wrote a small virtual machine controller based on mCollective that grew out of proportion pretty good. We're managing a lot of virtual machines with it, and it kind of works, but we now are hitting payloads that really require something else than a virtual machine. As much as we like virtualization, there's just some stuff like an Oracle database that is not going to be happy about virtualization, and eventually you have to support the guys that do it and give them a tool to do the right thing. So we need to support physical machines, and we're also heavily moving towards Amazon. So we have the same pipeline that actually serves Amazon as well. So you can write recipes for a data center in Nokia, or you write a recipe for a Nokia application, you can deploy it to a test lab, you can deploy it to production, and you can deploy it to Amazon. You don't change anything apart from a YAML file where you make a comment is like you want to have that data center supported too. If anybody does Amazon and Puppet, we came up with a pattern that was kind of nice, at least I think it is, where we run puppetmasters and repository servers within Nokia, and we just expose those to the internet on load balancers. But the repository is a two-side authentication SSL, mutually authenticated, and the puppetmaster does not auto-sign. So an Amazon host basically comes up and it knows how to talk to the Nokia puppetmaster, so the CSR gets issued. We have code within Nokia that then sees that some host issued a CSR, and we hook into the Amazon API to figure out if that host is legit. If it's legitimate, we sign the cert on the Nokia side, and that's also the certificate that gets you into the repository server. So this way, hosts in Amazon can basically come up, and they have the metadata that we need, the app role and release, attached as metadata on the Amazon host. So you can use flex scaling and all the fancy Amazon features while you still have a sensible Puppet setup and you don't make any decisions about authority in Amazon. So you actually make it on your home turf, which is a lot easier to argue in a lot of bigger corporations where people are pretty sensitive to putting any data out into Amazon. So yes, we need to be more agnostic to what is underlying. We really need to simplify the ENC, and that's also the reason why I didn't have a slide explicitly about it earlier, because I think it's way too complicated. The new backend makes it a lot easier, but if I need 15 minutes to explain it to somebody, that usually means that the design is not good. We want to release the major components, and there's actually the only thing that is at this point left is documentation. So the test pipeline, like all the Jenkins work that we did, all the packaging, all the test stuff, puppetmaster management, and a simplified ENC is hopefully going to be out in the next month or two, and available publicly. So if anybody wants to work with this or wants to run it somewhere, we're more than happy. That's it from me, and I think I've been a little bit too fast, but rather this way than the other. We're hiring, obviously. And yeah, I gave a talk a couple of weeks back about why hiring is hard, and I hope this will change my mind. But yeah, if you have any questions, or are there any questions about what we do here? Curiosities?
How many guys are in your team, for example? Because you said you're having thousands of people, and this looks a little bit like you wrote much of that yourself.
We wrote a lot of stuff ourselves. We're a tiny team. It was basically what I didn't say in the history. The reason or how this all got started is a bunch of pissed off system engineers that sat down and wrote something on a couple of weekends. It's, at the moment it is actually, so the guys that wrote it initially was basically 3.5 engineers. So 3 engineers and myself, and I'm kind of context switching between writing code and managing the team and the product. We're now up to, I hope I don't say anything, 6 guys, or 5.5. But yeah, my target is to be like more in the 8 or 10 people region, because there's a lot of crazy, stupid ideas that are still in my head that I want to get out, and I don't really have the time to. And I don't scale well. So the team scales a lot better than I do, and there's a lot of guys in the team that have even more crazy ideas, so we really got to do something about it. Any
More questions? Also, thank you very much.